Hi, welcome back. In part 4 of this series, we will design the interface between the client and the server and discuss the server architecture. The importance of interfaces in engineering cannot be understated. Here is a link to an open courseware with a video lecture by Professor Ollie de Weck of the MIT System Design and Management course. It discusses the importance of interfaces in the design of complex engineered systems. It could be somewhat advanced materials, but it is interesting and I highly recommend it. If you are a beginner though, it is safe to skip at the moment and just follow the tutorial as a recipe. You can start out with changing the parts of the recipe that you understand more. We will use the protobuf, short for protocol buffers language, to design the interface between the client and the server for our system. In this context, this language is sometimes called an interface definition language. The protocol buffers IDL has the concept of a service and request and response messages to the service. The physical server computer or even the same program can have multiple services that it offers. Here is the example from Avedi. In Avedi, the folders are arranged as follows. Avedi is the top level folder. There are separate folders for the client, server, and interface. The interface is defined in the garden.proto file within the interface folder. The generated folder is the folder where the Python code from the interface definition is kept. You can ignore it for now. Now, let's look at the garden.proto file. The first request-response pair is called the heartbeat. The heartbeat request has a timestamp and the reply also has a timestamp. The heartbeats are used by the clients to check whether a service is reachable or online. Each client will have a list of servers and it will ask the server, "Are you alive?" using the heartbeat request. If the server is up and running, it will respond with a heartbeat reply. The client will periodically send a heartbeat request, say every 5 seconds, and any server that recognizes this request sends back a response to let the client know that it is there. You can imagine why we call this a heartbeat. Some of the other interfaces deal with, for example, a way to list the plants in a garden, a way to get the real-time sensor readings from a plant, a way to get the historical sensor readings and actuator states in a garden. Getting historical readings could be more involved, and there could be multiple functions related to it. For example, there could be a function to query the date and time ranges of data availability. There could be functions to fetch the average data over a period, a moving average with a given window, or all the data points, etc. There could be a command to water a given plant immediately. In the interest of time, I will not go over the code for these interface definitions. They are pretty similar to the heartbeat interface definition and are available in the GitHub repository. Now, let us go over how the server code is organized. The folder structure of the server consists of some program entry code. Init.py is empty and used to indicate a Python package. Main.py just runs the server defined in app.py. App.py initializes gRPC and starts listening to process requests. It registers Garden as the object that actually services requests. When a request is received, the server code handles the request in the file gardenserver.py. The Garden class in this file has a method for each possible request in the interface definition. For example, here is the code for the heartbeat request. A feature of the code is the use of mock hardware to run and enable testing the code even when actual hardware is not present. For this, we use a design pattern called a factory. We have a configuration file called the serverconfig.ini, which lists configuration parameters such as whether we are running the server as a mocked-up system for testing or whether we are running the actual system. List of plants and their profiles. List of automatic control system parameters, such as averaging windows used for the servers. The factory initializes the hardware per the mock parameter. The hardware classes initialize themselves based on the remaining parameters. We will delve into a few more details of how hardware interfaces are handled in the next part of this series. Thank you.